So granted, if you're working on these problems and you're starting to realize that it's going to be a polar coordinate substitution, we've done it before, and for the most part, I think you can figure this out without going through all the work again. So let me put the integration down for you. Sine, I'm going to polar coordinates. It's going to be the root of, well, x squared plus y squared is r squared, and dA is going to be r dr d theta. The r is going from, it's a radius of 2, so 0 to 2, and the theta is going to go from 0 to 2 pi. Can I do the integration? I think so. But by the way, we're using a Jacobian to do this. But again, it's becoming more and more familiar to do more and more problems. What do you get over here? Let me write this down, 0 to 2, sine, r is a non-negative number, so it's going to be sine of r, dr. What's that going to be equal to? Well, it's going to be minus cosine of theta from 0 to 2. Let's write this down. So minus cosine of 2 minus a minus plus cosine of 0. Cosine of 0 is 1, so this will be 1 minus cosine of 2. Let's write that down. 0 to 2 pi. And this is a constant, 1 minus cosine of 2. And then it's going to be what? D theta now. What do you get over here? Relatively simple. Simple if I didn't make a mistake, by the way. Theta, 0 to 2 pi. So what do you get over here? 1 minus cosine 2, and then times 2 pi. Call it quits there, put a box on this. And let's take a look at the key, see if we got it. And I think I made a mistake somewhere. And maybe just plain sloppiness. And I got to figure out what happened. All right, so I'm going to say I made an egregious error somewhere. All right, so I'm going to say, where did I do that? Let me see if I got this written down right. I got the integration written down right. And maybe I just plain sloppy. So I'm going to erase all this business over here because my answer is so far away from what they said. At least I think it is. I'm going to do it again. I'm going to be more careful, though. And I think I see the problem now. And when I say I think I see the problem, just plain sloppiness. Let me write this down again for you. The integration I want to do, and I wrote down a really simple problem that wasn't the problem, right? It's easy to write something down that's simple, but this is not what they have here. I didn't put the r there. I want to do that. And I got to do that by integration by parts. All right? So last time what I did was I wrote it down without the r times the sine theta. So let's do integration by parts. And I'm going to do it, in a familiar way. I'm going to put as an indefinite x sine x dx. I'm going to say u equals x and du equals dx. And then I'm going to sine x dx equals dv, and v equals minus cosine of x. And I think I can write that down. So what do you get equals, let's see, uv, so minus x cosine x. What do you get over here? Minus a minus, That's going to be cosine x, and then dx. You got that over there. What's this guy going to be? Minus x cosine x, and then the antiderivative of cosine x is minus sine x. All right, let's write that down. And I gotta do the limits now. So what's this going to be? Equal to, let's see, minus r cosine r minus sine. I'm sorry, I made another mistake. This is plus. Sine r, 0 to 2. Let's see, minus 2 cosine of 2 plus sine of 2. And then if I do 0, it's going to be 0. So that works out pretty good. All right, so let's write this over here. I'm going to take this. I'm going to move it down here. This is going to be 0 to 2 pi. And it's going to be this constant. I'm going to write that as sine 2 minus 2 cosine of 2, and then d theta. And this is going to be equal to, let's see, sine of 2 minus 2 cosine of 2. And then it's going to be theta, and theta goes from 0 to 2 pi, so just simply 2 pi. All right, let's look at the answer, and I made another mistake. Pi sine 2 pi. Oh, you know what? I probably misread. Oh, I did. And what did I misread? This guy. I'm not going to do the whole problem over again, but quarter circle, I'm going to have to make some erasures over here. And the quarter circle is going to be up to pi over 2. All right, I'll get my eraser out again. Make another erasure over here. And that's going to be pi over 2, quarter circle. And this over here, let's put this down. It's going to be pi over 2. Pays to read, I guess, right? Am I getting the answer what they said? I don't know. Maybe I made another error. I made a lot of errors in this problem over here. Let's see. We got the pi over 2, sine 2 minus 2 cosine 2. Yeah, we're good. All right. So take-home message. I didn't read it. I missed this part. Does that happen when you're taking an exam? It sure does. Slow yourself down. I got cocky. I started saying stuff like doing problem after problem. They're all the same problem. Yeah, it wasn't the same problem. It was similar. What was it going to be? A quarter circle of radius 2. Let's go to the picture, see if they did a good picture for us. Yeah, picture's right over here. Probably should have paid some attention to that picture as well. Anyway, things moved along. We made some mistakes. A couple mistakes was just, I got cocky. I thought it was going to be really simple to do. It was simple to do, but I really should pay attention to what I'm doing. Thank you.